Alright, so we're going to introduce the idea of logarithms today, and there's a key idea to kind of keep in mind with logarithms, and that it's really asking for an exponent. It's a power. And so we have to read these things as we look at them. We don't want to just get blown away with the terminology or the symbols of what they are. Just keep in mind what they're asking. So we have some value x, and we can use it as an exponent, right? So where ax is in a power, so that's an exponential equation. And then we have some function, and then if we turn it around, that's called the inverse, and our inverse is going to be a logarithm. And so the question is, what does the inverse look like? How do we undo an exponent? And so we come up with this notation of a logarithm. So I have 3 times 10 to the x, and then x has to be 2. If we look at this example, right? And so that's 300, and then if I go the other way, I want the inverse of that thing. What is that going to look like? And so we try to break apart these things with some notation. So we would switch x and y and solve, right? That would be your starting point. If we were to just looking at algebra 2 level, kind of finding an inverse of an equation. And so if we were to do that, right, there's my values, that's my starting point. I would switch them, and I get x is 3 times 10 to the y. And I would solve, and I get 10 to the y. How do I get that thing down is our problem. And so I can't find that inverse. I can't get it down, and so we make up notation, or we make up a function, sorry, that deals with that, and that's called our logarithm. So we define something. And this looks strange. This is the part I was talking about. So we have log base b of a equals c. And we can use that translation to get to our pieces. A way that we read this is c is a power that we raise b to, and we get a. So that's going to be a key piece to keep in mind as we move forward. So we can ask ourselves that question, and we'll do it right. So c is a power that we raise our base b, and we get a to. Alright, so let's look at our example here. Right, we take a logarithm on both sides, and we can see that that's just y. Y is the power that I raise 10 to, and I get 10 to the y power, and our answer on the other side is log base 10 of x to the 3, and that's it. That's our inverse that undoes this equation up here. Alright, and so as we move forward, we can evaluate some logarithms. So here's a tricky one. Let's pick it apart a little bit. So we have log base 3 1.5, 3 to that power, and then 4 times 3, and what is that going to tell us? So let's think about what we have here. We don't need a calculator. It looks scary, but we can read our way through it. And so let's think about what this is. So we're going to read it, right? Log base 3 of 1.5 is something, right? That something is the power that I raised 3 to, right? And I get 1.5, alright? So it's some value, I don't know what it is, but I raised 3 to, I get 1.5. Well, that's exactly what I've done here, right? I've raised 3 to that number, and so what I should get by definition is going to be 1.5. So that whole thing is 1.5. So again, we can make it look confusing, but if we read through it, it won't be too bad. Alright, so that piece there is 4 times 1.5, which is going to be 6. So our final answer is 6. We don't need a calculator to figure it out. Right. And so now we have some properties of logarithms that we can kind of look through. And this is the same thing we looked at before. So x is some power that we raise b to, and we get y. We used a before. And we have some properties of the logarithms that we have below here. If we think about why does this work, so it's kind of strange. We're multiplying over here, and then we're adding over here. We have to keep in mind that we're talking about exponents. And what we would do when you multiply things with like bases, you add the exponents. And so it's the same idea here. 10 to the 6 times 10 to the 2, we don't multiply the 6 and 2, we add them, and I get 10 to the 8th. And again, since I'm talking about exponents, multiplication leads to addition. Division leads to subtraction, because we have the same thing, right? We'd have our pieces as we move forward. And so if you were to take those two things together, this is where our our values would come from on the one above it. But basically, you can add these two. You have 10 to the 8th, right? You're allowed to figure out these two values in terms of logarithms. That's just 8. That's 6 plus 2. That's where our logarithms come in, and you could substitute. Really, that's our 10 to the 6th, that's our 10 to the 2, and that's 10 to the 8th. So we can reason our way through all of these the same way, but again, it's just properties of exponents as we move through it. Right, so we could get all of these. We're going to use them a lot. The one we use the most probably is this one, where we can bring a power down in front. That's going to allow us to solve for our equations when we have these to get that exponent out. The subtraction we use, you may or may not use the change base a lot. That is very helpful when you're using something that has a base that's not a calculator problem, so we'll talk about the calculator in a moment. But you can change a logarithm base to anything that you want as we go forward. So those ones we're using the most if we're moving stuff forward, and we can look at kind of how that works. So we can expand these things into a series of logarithms. We just use our properties from above. So that's our power law. I can bring that in front, right? And then I have this mess of stuff to subtract because I'm dividing here. So my division leads to subtraction. And then I have another exponent I can bring in front, another exponent I can bring in front. And then I can break that one apart as well into multiplication, and then finally bring my exponent in front, and there we go, we have all the pieces broken apart. We've expanded it. Same idea here, we can go the other way, right? If I am subtracting, I want to go from left to right. If I'm subtracting here, I'm going to get a division problem, right? And so I'm going to divide from the subtraction. That's addition, which means that I multiply. And then I get my final value there as we move forward. Alright, so again, we're just using those properties. It looks big and scary, but those properties are really going to help us simplify equations. Right? So if we look down at the bottom here, we're going to write this as an exponential. And so if I look at our values, right, log raised 2 times 2 to the x, that addition means that we bring them together for multiplication. Right? This one looks a little bit strange, but I just switched the stuff around. I just subtracted and then I did the 3 to both sides. And now that means division. And I get to this point and you might think, well, how am I going to undo that logarithm? When you think about a logarithm is an inverse of an exponential. And so what that means is when I take 2 to those powers, that's like our first example, then I undo those ones, and I get x squared over 2 equals 8, and that's simple to solve. I multiply by 2, and I take the square root, and x is plus or minus 4. And we'd have to go back and check those values in our original pieces to talk about our restrictions on logarithms. We can't have a logarithm of a negative number, so we could see what those values look like. And so on this last example, we're going to eliminate these logarithms. So if we look at that, what that looks like, we bring those two together, right? And then we have, again, this value of x plus 1, x minus 1, and this is even easier. You have log base a of something, log base a of something else. Those somethings have to be the same. And so you get x squared minus 1 is 24, x squared is 25, x is plus or minus 5 as we move forward. And so again, we can look and check those numbers and make sure that they make sense. So we can solve these equations, right? We can make these work with our calculator. We have something that's maybe not nice, and it allows us to get exponentials down. So the log button on your calculator is base 10, right? You also have a natural logarithm on your calculator, which is base e, and so we can use our properties here to make this work. So we have 5 to the x power is 20. And so if I want to get at that exponent, I have to use a logarithm. And so if I take log of both sides, all right, now I can use my power law and bring that x down in front and get log 20 over log 5. Divide them through, right? And then you got to be real careful here. This is just like sine, cosine, or tangent. It's a function. This logarithm, you cannot cancel it. It's not just 20 divided by 5. Right? You're going to be really upset if you do that. And so what you need to do is you need to actually plug it into your calculator and get a value as you move forward. So log of 20 divided by log of 5, and you'll get around there. And that's from your calculator. All right, so you can solve the other one, same idea. right? And so this one you take a log of both sides, use your power law, you divide, you get some value, right? Now in this case, you divide it through by x and x, and you get 3 is not equal to this. So this actually has no solution, right? There's something that wouldn't work as we go forward. If you think about it though, right, we have those values, let's subtract them, right? So again, we don't want to divide by value because we can potentially be dividing by 0, which is our problem. And then bring them together with our factor out an x, bring them together with our power law and our division, and you can get x is 0. So we actually lost the solution on this one by dividing by x. So again, be careful, don't divide by your variable. Bring them together, factor them out, see what you can get as you move forward. Alright. In these, we can solve these ones without logarithms by just getting like bases. And so in this case, right, I have 2 to a third power is x plus 2, 2 squared is 2x minus 1. These are going to be powers of 2, and so we're going to be able to set them equal to each other. So those are equal powers, which means that those are the same. 3x plus 6 equals 4x minus 2, x is 8. And then on the next one, it's a quadratic. It looks scary because it's got e in it, but we can just factor those things out. We can let u be e to the x, and then factor it like that. U minus 2, u minus 1. Put your value of e back in, and now you have 2 exponentials to solve. And so this is the natural logarithm. That's always going to be 1, right? And so e to the some power is 1, x has got to be 0. That makes sense. Alright.